First I'll explain some of the features of the roulette wheel. Firstly, we've got the metal deflectors, otherwise known as diamonds, around the wheel. This wheel has 8 of them. We've got 4 of the vertical diamonds, and we've got the 4 of the horizontal diamonds. Horizontal because it goes that way, and vertical that way. Then we've got the rotor. The rotor is the spinning part of the wheel. We've got the pockets where the ball actually lands, the pocket separators, the metal part between the pockets, and the ball track. The ball track is where the ball actually rolls. It's subject to wear and tear. It's usually coated in a kind of epoxy resin. First of all, we've got a principle called dominant diamonds. We've got the diamonds here. Now, dominant diamonds is when the ball hits particular diamonds more frequently than others. Say for example, a wheel with 2 dominant diamonds, say here and here, the ball will hit these diamonds roughly 60-70% of the time. More often than not, you might find that the ball will miss these particular diamonds. Now that's not random, and we can actually take advantage of that. Another principle we've got is consistent revolution timings. Now, especially towards the end of the spin, with the last 4 or 5 revolutions, the actual timing for the revolution of the ball is reasonably consistent. So when there's, say, 4 revolutions to go, there might be about 5 or 6 seconds for the ball to complete those last 4 revolutions, hit that diamond, then fall. From that point, the ball might bounce, hit this diamond, and bounce about 9 or so pockets. So if we knew, especially on a rotor that's consistent speed, if we knew when the ball had 4 revolutions to go, we could look at the number underneath that diamond, and then we compare where the ball actually does land and might bounce that many pockets, and then we know from future spins, when there's 4 revolutions to go, that's where we place our bets. So just to recap, just to explain what I mean, we have a method, and there's a lot of different methods to measure the actual ball speed. But let's say, for example, we knew every time when the ball has 4 revolutions to go, before it actually hits this diamond or lands in this region, and then we know from there the ball mostly bounces about 9 or so pockets. What visual ballistics actually does is marks the point when there's 4 or so revolutions to go until the ball falls in that region and bounces again. Now let's say, for example, we've marked the point in time when the ball is here and there's 4 revolutions to go, and there's number 27 underneath the diamond. Then we wait for the ball to fall, and say for it lands on number 33. So on one particular line on a piece of paper, we'd write down 27, 33. That tells us the initial reference number is 27, and the winning number is 33. Then we count the distance in pockets between them. We repeat that process over about 20, 30, depends on the wheel, how many spins you need. It can be up to 60 or so. So repeat that and find out what particular distances most frequently happens. Now, you can also get a lot of different conditions, such as multiple peaks, bimodal, vis-a-vis, whatever you want to call it. There's a lot of different things that can happen, but this is only explaining the basics. Now, just for a bit of visual ballistics practice, we'll see if we can predict when there's one revolution to go. And when there's one revolution to go, the ball will be here, and we'll look at the number underneath that diamond. Now, you'll often find that you'll be a revolution off here and there. That's perfectly fine. All it does is just increase the number of peaks, but they overlap anyway. But that's a bit more advanced to get into that. So we're looking for when there's one revolution to go. It's really not hard to do. You only need to watch a few spins to know at what speed the ball falls. The more gradual the ball deceleration, the harder it is. Okay, we're getting close now. Now, probably the last revolution. Not hard to do. We'll try it again. Looking again for when there's one revolution to go. And we're looking, when there's one revolution to go, looking to know what number is underneath there. But just this one more time, we'll look for when there's one revolution to go. Almost there. Last one now, coming around. Okay, so it's pretty easy to do. And this is just for practice, that gets a lot more involved in this. This time we're going to be doing the same thing, but when there's one revolution to go, observe the number under that diamond. Again, you might occasionally be one revolution off, that's perfectly fine. Looks like about 6, maybe one more revolution, yep, 31. Okay, in that case, you'd write down 31, 23. So 31 to 23. You count back negative a few spaces, -9 or so. This is a crash course, so again, this will be the last one coming up now. 7, possibly another. Yep, that's right. Okay, so we've got 7 to 17. So that's just looking at the last revolution and the reference number. In the next part, I'll show you how to get a prediction much earlier with enough time to place your bets before they call no more bets. In case you were wondering, it was a lightsaber.
Help you, I can. Yes.
In part 1, you learned some principles that make roulette predictable. You also learned the basics of visual ballistics techniques, which is simply visually determining where the ball is most likely to land. In this video, I'll teach you how to get visual ballistics predictions much earlier, so you still have time to bet before no more bets is called. This particular technique is not the most effective you can get, but it's very easy to learn, which is why we're teaching it here. Let's get started. The initial aim is to know when the ball is at a specific target speed. When the ball is at this target speed, even on different spins, it will have the same amount of revolutions left before it falls. When we've determined the ball is at this target speed, we know which number on the wheel is under a specific diamond or metal deflector on the wheel. We call this number A. Then we wait for the ball to fall. We can call the winning number B. So over different spins, we will have lots of sets of data consisting of A, B, then on another spin is A, B, and so on. I'll show you an example. We start by observing the ball as it goes around. We wait for it to slow down. Now this is just an example, not an actual application. Just watch the numbers. Let's say, for example, and I'll pause it when the ball is at a particular diamond. Okay, so in this case, the number underneath this diamond when the ball is at this point is number 17. That would be our number A. and this is assuming the ball is at our target speed. Now we wait for the ball to land. And the ball lands on 1. So our first spin sample will be 17,1. Now we'll do another spin as an example. We're watching the ball as it slows down, and we're watching the number underneath this particular diamond when the ball is at a specific speed. Now I'll pause it when the ball, for example, the ball is at this target speed now. Our reference number will be 19. Then we wait for the ball to land again. And our number B will be number 5. So to this point, it's fairly simple. Now we need a way to measure the ball speed. We need to know when the ball is at the same speed on each independent spin. I'll explain this part next. There are many ways to do this. It does vary between wheels depending on what is possible, but the method I'm going to explain to you is a very simple method that pretty much anyone can learn. It doesn't take long at all. On most wheels, the ball does not slow down at a constant even rate. You will notice the ball starts off very fast for the first few revolutions, then suddenly drops in speed. You can see this occur without any electronic equipment. I'll just show an example. Watch on this spin. The ball starts very fast. It's a fairly even deceleration at this point. And watch for it to suddenly decelerate noticeably around about now. Now, at that point, the ball is the same speed on different spins. So if we were to play all the way to the end and repeat another spin, you'll notice the same effect. I call this the sudden point of deceleration. Other people call it different names, but that's what I call it. So once again, it starts off fast. Wait for the sudden point of deceleration. We're going through it about now. Okay, so what we're going to attempt to do is we're going to attempt to get the reference number, which is number A, when the ball is beneath this, above this diamond, and we're going to get the reference number at that time. That's number A. I'll give you an actual example. And at that point, I'm going to pause the video. So again, the ball starts off very fast. We want it to do a complete revolution after the ball is suddenly decelerated. Okay, so number 20 will be our first number. And 29 is the winning number. So what we've written down is 20, 29. Now we'll repeat this for as many spins as is practical. Generally speaking, for the average wheel, anywhere between 15 to 60 spins per direction. We're just going to do just a few, just because we're not doing a full course here. It's a bit of a crash course. So again, waiting for the sudden point of deceleration. Number 19. 19, comma, and we wait for the next, the number which is the winning number. Now, for this point, we're going to count the number of ball revolutions until the end. So it's 1, 2, 3, 4, 5, 6, This will be the last one. 7. So 7 revolutions, and then it undershot this diamond. So that's 7 revolutions. 28. Now we'll repeat this on a different spin. Number 9. So we write 9 comma, and we're waiting for the winning number for number B. $25. Now the object is to, when you take the number A, the ball is going to complete consistently the same number of revolutions, give or take 1 revolution. It's impossible for a visual ballistics player to have it accurate to 1 or less than 1, so you do have a margin of error, which is perfectly acceptable. How much margin of error is acceptable comes down to the wheel and the ball. So once again, waiting for the sudden point of deceleration, then 1 revolution after it, just to be sure. $20. And counting the revolutions. 1, 2, 3, 4, 5, 6. So the number is 16, and that was 6 revolutions. In the left panel here, I've got the numbers as we've been tracking. We've got the number A, this number here, and the second number, which is number B. After the dash, we have the number of revolutions remaining in the spin. So we take our reference number A, then the ball has 6 revolutions before it actually falls. So 6 revolutions past this particular diamond. So we're going to continue to track like this. Now, of course, this is not an easily beaten wheel, so you'd need realistically between 30 to 60 or so spins. We'll probably only do about 10 or so. We'll see how we go for time. Again, I'll be pausing it. Pausing it at the time when the ball has reached our sudden deceleration point. So 0 and comma. 2 revolutions, 3, 4, 5, 6. So the second number is 32, and it completed 6 revolutions. So again, as I was saying before, we're not always going to get the correct revolution down to the exact one. We're going to be out usually 1 revolution, sometimes 2. Pretty much 0 again. So 0 and 27, and it went around at 6 times. Next spin. $35. $35, 18. From now on, I actually didn't count the number of revolutions, and I think it might have been 7. Um, we'll just let the video run so you can practice. I won't actually pause it this time. You can see me in the panel here writing down the numbers as I see them. Would have been a little bit too far out on that one. It does happen though. Okay, that should do it for now. Now we're going to chart this data. Now what I mean by chart this data is we need to look at the distance in pockets between number A and number B for each spin. This chart here shows what I call the jump count. It's basically the distance in pockets between number A and number B. So say for example, if the value on the x-axis here is 0, that means number A and number B are exactly the same. A jump count of +1, or first of all, hang on, the scale goes from 0 to +18, and then from -18 down to -1. This is basically a circular chart. So that end here on the left joins up to the end on the right. Now, as I was saying, a jump count of +1 means that the ball has landed or travelled +1 pockets between number A and number B. And in this case, the bar is 2 values high, which means the number of times that has happened in our samples is 2 times. Now what we need to look for is a grouping of high bars, basically where this blue line is above this green line. It shows the average. This is the green value, which is the average value, and the blue line is just a modified curve. It tells us where the grouping of the high bars are. So in this case, they're highlighted by the green, which means in this area here, on the left of the chart, and on the right of the chart. Because this green area here, or the highlighted area here, is right next to this part here, we can actually join them up. And this basically tells us that the approximate distance that the ball lands from the reference number A to the actual end number B is around about the same point. It's not an uncommon situation, but it makes it easier to apply. Now, if for example this green area or the high bars were in the middle area, what that means is the area we need to bet on, which is where the ball is landing, is approximately 180 degrees, which is opposite number A. Now I'll give you some actual examples of application. These are our sample spins here. We'll be betting on roughly the same number as number A, covering about 18 pockets in that region, which is conveniently half the wheel. This number here is just the reference time in the spins that I'm using. So we want to get the prediction when there's about 6 to 7 revolutions before the ball falls. So 11. Okay, here's 11 here and 24. That'll be just counted as a win because it's within the 18 pocket arc. As I may have said earlier, you can afford to have quite sloppy application, and there are a lot of other methods that deal with the variation of rotor speeds, but this is a very simplistic method. Normally we would actually skip this particular spin. That's because the rotor speed's outside the norm. Actually missed that one, but it was around about 32, I think. That's number 8. 31. I was one revolution too far on that one. 23 and 4. 30. Again too far. If you're off a revolution, what actually happens depends on the speed of the rotor, the configuration of the diamonds. There's a lot of different variables. It can be a positive thing or it can be a negative thing. Basically, got a 50-50 chance. 0. It's important to keep track of the number of revolutions because over time you do get a bit sloppy with application. Like I can notice the data I'm obtaining now and the number of revolutions after number A, it's not as consistent as it is in the first set. So it just shows I'm doing something wrong or not as good application. Application is not as competent. You might have seen a visual ballistic demonstrations on the internet, although the wheels they use is a fair bit easier than this one. This is much more difficult. To anyone that doesn't know what they're actually looking at, it might look like magic or cheating. It's actually a very basic thing. We'll just do this one more spin, then we'll have a look at the chart. This chart here is a representation of the second set of spins. These are the spins where we've actually played on. Now, as you can see, the green areas are much in the same area. The green areas represent the peaks or the high areas. This is a proper statistical analysis. So on the left-hand side, we've got the green area, and on the right-hand side, we've got the green area. We've got a secondary green area in the center, but the main areas are the left and the right, and that's exactly where we were betting. So in this situation, we would have clearly profited. Now, in this technique that I've actually taught you here, again, I have to say that it's a very, very simplistic technique. Anyone can use it. There are certain circumstances, of course, where you can't use it, but this is by no means the most effective visual ballistics techniques there is. There are techniques that deal better with the variation in the rotor speed. With this particular technique, what you need to do is you need to stick with rotor speeds that are much the same speed. So if you find a dealer spins the wheel or the rotor far too fast or inconsistent with the other spins, then just simply skip that spin. Now, with the actual the genuine winner system, while I do teach visual ballistics and more advanced visual ballistics techniques, generally there are two techniques I don't like, and that's visual ballistics, which is what I've just taught you, and bias analysis. There are a few reasons for it, but comparatively they're older techniques and not as effective as what is available with the modern techniques that I teach.